page 20. So they're asking us to find the slope of the tangent to this function at the point 3,4. So notice here they actually give us the y value. So in order to find the slope of the tangent, we have now defined that as being the limit as h approaches 0 of our slope of a secant formula. So that's f at a plus h. So in this case here, our a value is 3. That's the x value at which we want to find the rate of change. So it's going to be f at 3 plus h minus f at 3 all over h. Okay, and recall that the idea here is we want to see what this expression is going to approach as h approaches 0. And the way we do that is by keeping h variable and trying to reduce the expression. All right, so let's go ahead and just input our information. All right, so here, just wherever I see an x, I'm going to replace that by 3 plus h. So that's the square root of 25 minus 3 plus h squared. Okay, and then minus, well, they've already given us f at 3. We know it's 4, so we don't have to calculate it ourselves. All right, and now what we try to do is see if we can do some algebra with the eventual goal of reducing this h from the denominator. All right, so the trick we saw was that when we have the variable that's stuck inside a square root, we can use the idea of rationalizing to get it out of the square root. So what I'm going to do is I'm going to multiply both numerator and denominator by the conjugate of this expression, because this is the square root that I want to eliminate. So I'll multiply that by square root of 25 minus 3 plus h squared. And here, instead of minus 4, it's going to be plus 4. But of course, if I multiply that to the numerator, I have to do the same thing to the denominator. All right, so again, notice how I write the limit notation every single time, because I've yet to determine what this approaches as h approaches 0. I only get rid of that notation once I get to that step. All right, so the nice thing about this here is that it creates a difference of squares. So these middle terms, when I do the multiplication, always cancel out. And so I'm just left with this first expression squared. So in other words, gets rid of the square root. And this is where I'm now going to, well, to try to save myself a step here, 25 minus, and I'll expand this 3 plus h squared. All right, so that's going to be 9 plus 6h plus h squared. So remember the old trick, square the first, square the last, twice the product of first and last. So 2 times 3h, 6h. All right, notice here, I make sure I put brackets around the 3 plus h squared because the whole thing is being subtracted. And then, of course, I've got my other square, so minus the square of 4, so minus 16. All right, and all this over h times, and this whole expression. Here, I'm not going to bother expanding it. Okay, and notice how I don't multiply the h into that bracket because I know that eventually my goal is to reduce that h out of the denominator. So this is just square root is 25 minus 3 plus h squared plus 4. All right, so let's see what happens. And I see some nice things are going to happen here because 25 minus 9 minus 16 just gives us 0. All right, so now what we have in the numerator is we see that we can factor out an h. All right, so here we've got negative h. Okay, don't forget the negative there. And what am I left with? Just 6 plus h. And then, of course, I've got this whole thing. Okay, and we get exactly what we wanted, which is the h's to reduce. And so now I can actually determine what this expression approaches as h approaches 0. Okay, and this is where now I'm not going to write my limit notation because I'm actually about what we say we're evaluating the limit. So here I've got this negative, and what does 6 plus h approach as h approaches 0? Well, it just approaches 6. So in the numerator, I just have negative 6. Okay, in the denominator, well, all these constants still approach whatever they are because they don't depend on h, but this expression in the bracket, 3 plus h, approaches 3 as h approaches 0. So in the denominator, we have square root of 25 minus, that's just going to be 3 squared, and then plus 4. And let's keep simplifying here. So negative 6 over, so this is 25 minus 9 is 16. Square root of 16 is 4. 4 plus 4 is 8. And so I reduce that and I get -3/4. All right. And so that tells me that the slope of the tangent to this curve at the 0.34 is -3/4. Okay, so presumably, if I were to graph this, and we can graph it on Desmos, you would see that at 3,4, the slope of the tangent would be negative. Okay, so just to recap, all right, we are still looking for the slope of the tangent to a function at a particular point, all right, but instead of finding an approximation, this idea of a limit allows us to determine the exact value. And the way we do that is to take the expression for the slope of the secant and reduce it to the point, okay, as we had here, reduce it to the point where we can determine what the expression approaches as the h gets closer and closer to 0. Okay, that's it for this one.